Welcome back. Now let's look at functions. We are done with relations, the types of relations, and we are going onto functions. Now, before I continue, if you remember, we said one-to-one relation is a function, and then many-to-one relation is a function. Now, let's see why we said this. Let's establish these facts. So, functions is a relation in which each element in the domain is mapped onto one and only one member in the codomain. So it means that here is mapped onto one. It cannot map onto other numbers. So only one and nothing else. So that's what it means. So let me read it again. It's a function in which each element in the domain is mapped onto one and only one member in the codomain. It's as simple as that. So this cannot be mapped to another element and onto another element. So only one. Now here is the same thing. Here is the same thing. I think you may get a bit confusion, but it's not a confusion because Q is mapped onto one. So it doesn't matter if there's another element sharing it. It doesn't matter. That is why we said that one-to-one is a function and then many-to-one is a function. So here and here, this and this, they are many. They are mapping to one. So that is why one-to-one is a function and then many-to-one is a function. So that is it. Now let's come down to this particular one. Here, the same thing is true here. The same thing is true here. But here, there's a problem here. The problem is here. So because there's another subordinate aspect of the word, the sentence, that the condition that we read, that one and only one member in the codomain. So if you are here, there should be a map onto it. So for instance, if you look at F has no image. F has no image, hence this violates it. But here, A maps here, B maps here, and then this is not. This will also be a problem because this is what there should be either many one-to-one or many-to-one. C alone is having two images, so that is wrong. Right. So now let's continue. So with that established, let's now go a bit deeper. So we are looking at one-to-one function, and one-to-one function. We are saying that one-to-one function is a function, right, in which each element in the domain has only one image in the codomain, and each element in the codomain is associated with only one element in the domain. So here you are being distinct. We said that for the functions, right, under the relation, there are two types: one-to-one or many-to-one. But when it comes to one-to-one, we are being specific. So it means one mapping only one-to-one. Unlike here, where this was mapping to this, and then this was mapping to this, right? So that is it. So we are being specific, one-to-one. So connection straight. An image here will not be sharing two inputs. That is it. So if you should draw here means that this is okay. This is it. It's sharing one. Okay, now this is not a function. Now let's read why it's not. Now the function defined in one above is one-to-one function, since each in the element in the domain has only one image in the codomain, and then each element in the codomain is associated with only one element in the domain. Now the function defined in figure 1II is not, so you see it's not, since one-to-one in one-to-one function, since two elements of the domain, -1 and then 1, they are sharing the same thing. So that is wrong. Right. So now there's a functional notation. That is when we have to deal with calculations. So how it is written, a functional notation, how it is written, how it is represented. So that is, so we have if f of x is equal to 2x plus 3, then by definition f of 1 is equal to 2 into bracket 1 bracket close plus 3, which gives us 5. Now this is one of the topics in math that I love so much. is more of substitution. If you understand the concept, the wording, as in yes, the rest when it comes to the calculation itself is very easy. So it looks as if the explanations when it comes to they are a bit to grasp when it comes to the explanations. But when it comes to the calculations, they are very, very easy to understand. That is what I've realized. And this is how it is actually. So you would appreciate that if I should give you the explanation, it's far, far better. So if you get the explanation, then the calculation will be easy peasy. So that is it. So here, basically, when it comes to the calculation, we are just substituting. So where you see x, it means that the figure that we put there is the figure, the variable, right? So if you are saying 1 is in place of x, then you put 1 here. This is how it is represented. It's more important when we are doing the written form. So we put this one there in place of x, then now 2 into bracket, x now is 1. So you put it there and then you do your substitution, you do your calculation, add, addition, subtraction, you get it. You do for the various values of x. So sometimes you can be given this set for the domain. I ask you to get the image or the codomain. So this is where the calculations come in. So it's simple as that. Now we are saying that note that f of x means that the image of 1 under the function f. So that's the image. Now in general, f of x means that image of x under the function f. Yes, mathematics or just English. So also, if you have h of x is equal to 2 plus x all over 1 plus x, wherever you see x, the figure that you are dealing with, just split it there and you know your arithmetic operations. You just deal with that. It's as simple as that. So in some situations, when they give you this, they may give you a condition at the end of that calculation, what is expected of you. So after doing the calculation, though be in a haste, check that everything, the conditions set in the question have been met. So the same thing is applicable here. So here you see s squared plus 1 is the same thing. You have been given the domain, which is 1, 2, 3. Put them in the equation. You see? So that is it. So now that you have this one, you map them. And this is how it is represented. X mapping onto this. So I think with the functions, we are good to go. Every other calculation that comes under this, you will be able to do it, right? Right, so the next topic will be mapping, where we come up with a rule or a formula to get the answer, right? So it means that in functions or functional notations, if you have been given f of x is equal to 2x plus 3, this is actually a formula that you have been given. So with this formula, when the codomain is given, you can get when the domain is given, you can get the codomain. And in fact, and vice versa. Or you can also get the range, right? So that is basic calculation. Now in the mappings is where we will be using this one will be given, and then we will rather be looking for a formula, or better say the rule or the principle. So you'll be given something of this sort, and then you have to derive the formula. I think we are getting the picture. So please like, subscribe and share. Check on the channel, other videos. We have a structured playlist where you can revisit anytime that you need them. Please like, subscribe, share. Let's hit Operation 1K, and then we can start coming live. We will see you soon. Bye for now.